Hello, this is Stu with Autel today. We got a 2025 Hyundai Palisade. We're going to go through a couple calibrations today. We're going to be using our IA1000. We got the Ultra S2 scan tool in my hand here. We're going to go through really the whole procedure, how this works, step by step. Let's do front radar. Okay. We're not going to need this target board anymore, so I'm going to get rid of this target board. All right, check if the wheel alignment and the tire pressure of the vehicle are normal. Why is that important? Well, obviously, if the wheel alignment is off, and let's say that the car is doglegging down the road, that radar would be looking, instead of straight down the road, could be potentially looking off 5 feet, 10 feet, 20 feet, 100 feet, depending on how far away the vehicle is in front of it, and your system would not work correctly. So I'll say this, I say it all the time, but I'll say it again. The physical is even more important on ADAS calibrations than the electrical. Okay, so we got to make sure wheel alignment is performed each and every time. If it's not being performed, we've skipped a step. And we don't want to skip steps, we want to do this the right way. Okay? This is also saying under normal conditions, after checking the front bumper for any deformities, we want to make sure there's no contamination, right? So typically what we would be doing on this is let's make sure everything is clean. Let's make sure everything that our physical is right on our radar module. So there's a horizontal and a vertical check. The only way to do that is we're going to have to remove the front bumper, okay? As we walk through this, what we're going to do, we're going to do a calibration without removing the front bumper, without checking that horizontal and vertical step, okay? All right, so there's two modes here. There's a dynamic, which would be driving mode, and then parking mode is our obviously static, okay? So what we're going to say here, do sensor unable to recognize vehicles. Here's our two different methods. We can use the old plumb bob method, or we can use our new high intensity lasers, which we're going to use B. We also can pick which corner reflector we want. We can use either the aftermarket, which we use on a variety of vehicles, or we can use the actual OE specific corner reflector, the 802.11, along with the laser emitter, the 802.13. Okay, we're going to go ahead and use the aftermarket in this particular example, and then these are the things that we do need on the calibration side. What tools do we need to do this calibration? You're going to see these high intensity lasers, which is the 2-line laser, and then also our wheel clamps, our distance target, and so forth. All right, park your vehicle on a level surface. Make sure the radiator grille sensor cover is all clean. Everything looks good on this particular vehicle. There was no codes present whenever we started this whole process. We're going to hit our start, and our frame is going to go ahead and zero out. Okay? Crossbar height will be the last thing as it goes to its starting position. Okay? We've already got these on the rear tires since we did our forward-facing camera calibration already. So that step, as you can see here, we're going to take on the right sliding plate, we're going to take one of our lasers, which I have right here, put it on the right sliding plate, turn off the switch of the 2-line laser. Okay? We need to get our values right here. So I'm going to go ahead and move the frame to the 2664 distance that it's asking for. Okay. Lock it in place, hit next, and the frame will automatically adjust for any variance that I may have. As you can see, the camera boom went ahead and completed that process for me, which is a very, very nice feature. Okay, can move this around. Just gonna take our target height. Our sliding block is gonna go into the right position. As you can see here, it's gonna go to the center. And we've actually 360'd the car. Now we're gonna end up placing a laser on the floor, and we're gonna be able to place, please open to turn on the 2-line laser and mark the X. All right, we have our laser shining on our spot. For our first spot, we're gonna take some tape, and we're also gonna put a marker here, and we're gonna mark this spot real fast. When we do this, then we'll be able to move on to the next step. Okay, there's my first spot. We'll hit start, which it should automatically go to our next spot for our next angle. Just be careful, make sure there's nothing in the way of that sliding plate when it is moving. Okay? After sliding plates move to their target position, press next to enter the next interface. Okay? As shown in the figure, mark point A at the intersection of the cross laser line to release the brakes of the base, move the calibration frame out of the way. All right, so we have our spot exactly centered from the center of the vehicle. Okay? We do need to move our calibration stand up out of the way, which we can do now. I'm going to move these up because it just makes it a little easier to move the system out of the way. Corner reflector, we will set it up into position. We'll turn our laser on. We'll center it up right here. And center up that laser into the radar module itself. We want to adjust the stand. We want to make sure that everything is in check here. We've already centered the base, so we're good there. We've centered the laser so that it's right in check with the radar module. We're at 396 millimeters on the stand. Okay. All right, so there should be no obstacles in the way. That's why we had to move the stand out of the way. We'll go through the calibration itself, and it's failed the first time. Calibration successful. I moved this corner reflector to 425 to hit the spot. On our last part of the video, we showed calibration on the radar was a failure. We ended up moving up the corner reflector 450 millimeters, which is quite a bit over spec. Spec is 396 millimeters. As we look at this placement of this radar, mine is setting at almost 0 degrees. The reset value for this particular radar is a negative 1.2. That explains why I had to go to 450 millimeters to get this thing to calibrate and to pass. You're able to see the reading here. We're at 0.1 on our angle finder. We should be setting more like 1.2. So I need to do an adjustment. We're going to pull out our corner reflector and we're going to place it on the spot. Turn our laser on. We'll get it set at 396. Calibration successful. So we measured a perfect 0 degrees. To me, this is everything because of our physical angle check. If you remember, we were looking at almost a 1 degree variance before on a failed calibration. This went right through the first time, right after doing the physical angle check and actually doing the actual measurement there. Anyway, this is a nice vehicle to show the physical on ADAS, is how important it really is to perform all the necessary steps. Pulling a bumper can happen even on vehicles that are not in an accident. This vehicle's never been in an accident. It's got under 20,000 miles on it. It's a 2025. The radar needed adjustment. It probably needed adjustment since it left the factory. I noticed this thing didn't drive quite right when I did drive it to the shop here. So case example, if you're performing wheel alignments, you're doing any type of repair work, calibrations are extremely necessary. Pulling bumpers and checking radar and doing the physical checks on radar is a huge, huge, huge deal. And we need to get all shops doing this. Thank you. Hope you learned a little something today. We appreciate your time. We appreciate you coming in to check out Autel Academy. Come to our training facilities. Come check out all the things that we do. We got thousands of tools, thousands of customers that are doing this each and every day. We want to help you do it the right way. Come over to Autel. We're here to help you. We want to give you everything that you need in one tool, if possible, and give you the skills and the knowledge to take you to the next level. We appreciate it. Thank you.